All right, let's get started. Thank you so much for joining. Welcome to the session on Design Patterns Revisited in Modern Java. My name is Venkat Subramaniam. I want to first start by saying programmers love design patterns. Some of us probably had that for breakfast today, isn't it? Well, when you think about design patterns, I want to start with a story. You've been telling how amazing grandma's pie is to all your friends. And they finally say, you got to make grandma's pie. So you call grandma nervously and say, Grandma, I'm in trouble. My friends are coming over on Saturday. I got to make the pie for them. Give me the recipe. And grandma says, oh, take some flour, take some sugar. Wait, slow down, grandma. Give me the recipe. What are the best practices? You write them down, and then you make that pie. How did it turn out the last time you tried something like that? It was a disaster. I know. I tried it, exactly the result I got as well. I lost some utensils with it. Then you meet grandma the next weekend. You say how terrible this whole thing was. And grandma says, why don't we make pie while we talk? And then you're watching grandma make pie. She takes 2 teaspoons of sugar, measures accurately, and puts it right. No. She's having a great time talking to you. And while she's talking, she takes some sugar, throws it in, and said, whoa, what was that? She says, sugar. How much did you put? Enough. And that's when you realize grandma doesn't use the recipe she gave. Where I'm going with this is there were 4 guys who wrote that fantastic book, nearly kind of scary to think about it, 30 years ago, called the Gang of 4 book, the Design Patterns book. They are the grandparents of the industry. And I think the only thing they did worst in their life is to write the damn book. And everyone thought we could do this too. And it's a disaster. Now that I motivated you so much about design patterns, let's talk about design patterns. But before I go into it, the reason I want to emphasize that is I don't find design pattern, honestly, as a good design tool. I don't. I find design patterns as a phenomenal communication tool. So I use design patterns not to design my software, but I use design patterns to communicate how I have designed my software. So it's a great way to engage your group and say, here's an approach we can take. Here's how we kind of evolve the design towards where we want to. So given that, let's talk about a few design patterns and maybe a few anti-patterns as well, but specifically related to Java in general. But I want to start with one thing that was introduced in Java, which is the optional. And of course, when something is introduced, we all try to understand how to really make good use of it. Sometimes we make good use of it, sometimes we make misuse of it. But I want to spend a few minutes talking about optional just for a few minutes. Let's take a little example here just to entertain this thought. Let's say we have a function, let's call this as a set name, if you will. And I'm going to take a name here as an argument. And I want to talk about the old code, which is legacy code. We all have seen it. We have production code written like this before. And what did we notice? We probably see something like if name is equal to null. Anyone here who loves null? Nobody, right? But we always deal with it. And I'm going to say null is a smell. I'm not a fan at all of that in here. And in this case, of course, we do some default value I want to set if this is the case. Otherwise, we're going to use the name given, right? So that's basically the code we're going to be writing. Now, when optional came about, some people got really excited. And so they said, hey, here's an idea. We could turn this into set name optional, if you will. And then, of course, in this case, we could say, here's a string. We'll call it as a name that's coming in. And I want to just make sure that we document this before anybody takes a photo. I'm going to say bad idea. Don't do this. This is terrible anti-pattern in my opinion, but yet people get excited about it. Now you may look at this and say, what could possibly be wrong with this? Because after all, I can say if name is present or if it's absent, I could take some effort with it and I could write the code like this, and why not really seems like a good idea. Well, the reason is we don't see why this is so terrible when we look at this code, but I want you to shift your focus for a minute and think a little bit about the user of this code. How is somebody going to use this particular function we wrote? They're going to say set name optional empty if they don't want to send anything. And then, of course, they're going to say, in this case, if they really want to send the data, they could say optional, off, and maybe whatever name they want to send to this. Now, how would you feel as a user of this code if you're going to do this over and over and over? One thing we want to keep in mind is that we want to say code should reflect, I want to say, empathy. We deep down ask the question, how does one feel using this code? And I would feel terrible using that code because I got to keep sending optional empty. So what's a better option than sending optional? My first recommendation is do not use optional as a parameter to a function. That's a really terrible way of writing code. Instead, what you really want to do if you want to facilitate something like that is to provide an implementation of setName, which takes no arguments, and then, of course, one that takes an argument. And again, I'm using this as an example, but something more significant you want to pass to it. Now, the benefit of this is the caller can have a really good time. They just simply say setName, or they call setName and pass whatever they want to pass to it. That becomes a lot easier to write the code rather than sending optional. So receiving optional as a parameter makes really no sense. We shouldn't do that also. Now, obviously, then the question is, would it make sense to use option as a field? And it doesn't also, because it's purely internal. What are you trying to protect? That doesn't really make any sense. In a similar way, you may ask the question, if I say optional of string, get name, isn't that a great idea? I thought this was a great idea until I really, not even making this up, caught a developer returning null from that function. There is no way, right? This is, oh no. So that doesn't make any sense at all. When you think you have made something foolproof, a bigger fool shows up, right? So absolutely, that doesn't make any sense. So don't do that either. So there's no guarantee that this is not going to run into a null pointer exception. But of course, on the same token, suppose you have an optional, as an object. How do you get the value out of it? My recommendation general is or else is a great function because you can tell what you want from it. And if it is not there, you can provide an alternate value. That is a nice function. However, what about optional.get? This is also a bad idea. And the reason it's a bad idea is, remember what optional is trying to do. It tries to eliminate an accidental exception from our code. Unfortunately, get kind of defies us on that because when you call get and the object doesn't exist, it blows up. So that's really a terrible function. And not because it blows up, it is because it blows up without telling really clearly that it's going to blow up. If you really want to do that, a better approach is or throw or else throw. And this is really the same as the get function, except it's very clear of its intention. And that's one of the things we often follow in good programming practice is be very intentional about what you do. So don't use get. If you really have to use something that blows up, use the or else throw. That's a much better solution in general. So those are some of the recommendations when it comes to optional. So let's move on a little bit and talk about a few other patterns. Now, one of the patterns we all have used in the past is the strategy pattern. Now, if I want to refresh your memory about strategy, what did you do in the past when you used strategy? You probably created an interface. Then you created a bunch of classes that implemented that interface. Then, of course, you received those particular interfaces as a reference or stored as an object. And by the time you are finished doing it, you don't remember why you started doing this. So that's a lot of code to write, which is unnecessary. But where did we really go wrong? The problem really is strategy fundamentally is a pattern related to functions, but somehow along the way, because of the ideology of programming with classes and objects, we started wrapping functions into objects, and then we lost sight of it, and we started really passing objects around and creating classes and hierarchies of classes, which is really heavyweight. Let's rethink about strategy, how easy it can be. But for this, let's take a little example to play with. So imagine you have decided to meet some of your friends after a very long time, and you've been talking about this for months on end, and it's that Friday that you're going to meet your friends. You've been talking about this at work all along. But on that Friday, you're eager to go meet your friends. one of your colleagues, the one who nags you all the time, wants you to write a function to total, let's say all values. These could be values which are prices of a stock or various other values in your application. They want to simply total those values. So list of integer, let's say, in this case, values, and how do we really total these values? Let's keep it extremely, straightforward, and we can refactor this later if you want to. We can say result is equal to 0, and here comes the result we want to return. And just as an example, let's go ahead and call the total all values. And here, let's go ahead and send maybe a numbers that we want to send. So we can say values is equal to list of. Let's just send a bunch of values just to play with it here for a second. So given these values, I want to pass them to the total all values. But what is the total all values function going to really do? We can say here is an integer I equal to 0, or maybe we'll just say I equal to 0. And then maybe we'll bring in all the values. Let's say number that's coming from the values, if you will. And let's say result plus equal to the given number, and we can total it, right? So very simple. And as soon as you're done, you are really eager to go to that event in the evening, and you're getting ready when your colleague unfortunately comes to you and says, I need another function from you, which is total all even values. And your mind is not in writing the code. You want to go to that party you've been waiting to go. And you say, let me understand, you want a function total all the values, but you also want another function total all the even values. And your colleague says, yep, that's exactly what I want. And you're thinking, how do I write that function? And then you tell yourselves, there's got to be a reason why they created copy and paste, right? I mean, if nobody should use it, why would you have such a fantastic feature? In fact, it's so incredibly done. You just highlight a piece of code, and you do a Control-C and a Control-V. How cool that is, right? So amazing feature to implement. So you copy and paste that function. You say, here, change it to all even values. And all that you have to do is simply say, if the number mod 2 is equal to 0, then total, not otherwise. And you can run the code and it just works. How cool that is, right? So you get that working. And as the fate may have it, a few minutes later, your colleague now tells you, but I need one more function from you as well. I want to total odd values. And you realize copying and pasting a code a third time is an act of criminal negligence. But nobody is looking, so why bother, right? So now you know where this is going. This is not going to be ending up fun. So how do we really deal with it? Let's pretend this never happened for a minute. Let's just roll back the change that we made. And here is the code we had originally. And your colleague says, I want you to total all the even values in the collection. And you understand what the requirements are, and you realize, before I implement that particular code, maybe a little bit of refactoring would be really nice. So we can go back here, and we can bring in a function, in this case, a predicate, and we can say, here is a predicate on integer, and we'll call it as a selector. And as it turns out, we can simply say, if the selector test of the number is equal to true, then go ahead and do the addition. If not, don't bother using it. So then we can refactor this to say, given a number, whatever that's coming in, I want to return a true. So with that little refactoring, we can now make use of this really quickly by saying, hey, given a number, I want to say number mod 2 is equal to 0. And now, of course, I can simply total all the even values. Or if your colleague wants to total all the odd numbers, you can tell them to go write the code themselves. So in this case, you can simply say a Boolean. Maybe we can say is odd, where it takes the number right there, and you can simply say return a number mod 2 is not equal to 0. And what's really nice about this is you can simply go back to this code, and you can simply pass that particular function reference, if you will, and as a result, you can simply simply find the total of all the odd values as well very easily. So as it turns out, as you look at this particular code, this is simply a use of a strategy pattern, except that your strategies are really functions fundamentally, and of course lambdas are anonymous functions, so this becomes a very easy way to implement the strategy pattern. You don't have to sit there and create classes after classes in this case, simply write those functions. You can even write a utility of those functions and then pass them around as method references if you really wanted to, and as a result you can implement the strategy pattern, and while your colleagues are still having a corporate design meeting how to do this, you can get your work done and go home. So that becomes a very lightweight use of the strategy, as we can see in here, thanks to lambdas that can be treated as strategies, if you will. So this brings us to yet another thing that I want to talk about. And what really intrigues me about language is, to me, a language design is application design. So when a language actually matures, you are able to use the design concepts really much better in implementing your applications. So I want to look at default methods in a slightly different light. I want to look at default methods as a form of a factory method. So let's entertain this thought just a little bit in here as an example. So let's say we have an interface called a pet, and I want to create maybe 2 pets here, and you could have it as a class here if you really wanted to, that's fine as well. So in this case, I want to create a class here called dog, which extends pet, let's say, and we also have a cat, let's say, and that extends, let's say, the pet as well. So we have 2 different classes in here. But I want to create in here maybe an interface, let's say, called a person. And this person interface contains a function here. We'll call it as a default play function, which plays with a pet, let's say pet, and a person is going to play with a pet. So we'll simply say playing with, and we will simply display the pet that's given to us. So in this particular case, I'm going to change this a little bit and not really pass a pet to this particular play function, but where's the pet then? Well, this is a nice, interesting idea where you can write a default method, but remember, interfaces cannot have mutable fields, so you cannot put a field called pet within a person interface. That wouldn't compile, that wouldn't work. So where is the pet going to come from? So this is where we can use something like a factory method. I can turn this into a getPet as a function. So where the getPet function could be a pet, and that's going to be returning, in this case, a getPet, like so. So in other words, we can write a function that's abstract, that's not implemented, which can work as a factory method, and those methods can be implemented by derived classes, and we can use them. So for example, if I say class, let's say a dog person, and I'm sure there are several dog person in this room. We love dogs, and in this case, I'm going to say implements person. But what am I going to do in here? We could say a pet, and in this case, it could be equal to a new dog. We could have our adopt a dog. We can write more methods and functions for it. And that's all I have in here, except we could write a getPet function like so. And in this case, the getPet function can simply return the pet that we have right in here. So as an example, let's say we have a function called a call, and we take a person as an argument. And in this case, I want to simply call the person.play as a function. You could call the call with the new dog person and the person who really enjoys the company of a dog, and you can pass it around, and we can call this particular function here. Of course, that's a default method, doesn't return anything, so I'm going to simply say a void. So that's basically the playing with the dog. On the other hand, just to illustrate this, if I say over here, a cat lover, and implements the person. And you may wonder why I did not call it as a cat person. Because there are no cat person, you know this, right? Because dogs love you, but cats don't. So that's basically, you can only be a cat lover in this case. So just kidding, but only partly. So essentially in this case, we can say, we can define a pet in this case, of course, and that's going to be a pet is equal to, we could say, a new cat. And in this case, of course, I could write a getPet function again, but that's going to return an implementation that's local to this particular class. So going back to this particular code, we can simply say over here, cat lover again, and you can run that code, and it's going to be working with the cat. So essentially, we could think about a default method as that provides a partial implementation, but then the interface can have abstract methods that can serve as a factory method. So what is really nice about this is we can capture some common behavior in the interface, but really have the derived classes refine the actual implementation by way of the factory method. So this is a way of thinking about this as a factory method pattern, and default methods along with abstract methods can really provide that capability for us, and we can benefit from that, as you can see. So that brings us to two of my favorite patterns. And I want to spend a few minutes more on these two patterns because they're really, really powerful in what we can do. But before I go into the decorator pattern, I want to show you an amazing capability that you have with the functions. When it comes to functional programming, one of the ideas that's really interesting in functional programming is this idea of function composition. A function composition is where, much like, for example, if I were to take a pen and ask you what it is, you're going to say that's a pen. But I can start removing the lid of the pen. I can take the parts separately. And now I ask you what it is. You could name each of the part, but I can put the back to as a pen. But you can go any number of levels down. You can go into atoms and molecules and protons and electrons. And that can drive us crazy thinking about those details, or we rely on the abstraction, it's a pen. Similar to how we use object aggregation, we can also use functional aggregations as well. So in other words, how you can create bigger objects using smaller objects, you can compose functions to create bigger functions from smaller functions as well. Just as an example here, let's take a look at an example to illustrate this point. We'll call it as a print, and I'm going to take a number and a string, which is a message, but let's also go ahead and take over here a function which takes an integer, and it also returns an integer. We'll just call it as a func right now, and we're going to use this particular function in here. So let's go ahead and bring in the function right there. And now, if in this case I'm going to output the given number plus, let's also output the given message as well. And then let's go ahead and output, let's say over here, func.apply. And we will call the apply and pass the given number to it. So here's a very simple example of just a function we're going to create. So I can say here is a function which takes an integer, and here's a function that takes an integer and returns an integer. We'll call it increment, which is going to take some number, and all it's going to do is to say number plus 1. And we can call the print and say 5 incremented, we'll call it incremented, and we can then say, in this case, let's say an inc, and we can pass it. Similarly, we can say 6 incremented, so 5 incremented is 6, and 6 incremented is 7, and we see that in the result here. But if we go back to this code and say, hey, we'll call it double it, and that's going to take the number and double the number. So in this case, we will simply say 5 doubled and 6 doubled as well. So as you would expect, 5 doubled is 10 and 6 doubled is 12. And that's what we were expecting in this case if I write this properly. So we'll say double it. So in this case, of course, we are going to call the double it function, and that's going to be a double it function as well, and 5 doubled and 10 doubled. However, what if I really want to take the 5, but I want to say, in this case, incremented and doubled? Now, if I want to write this code as given a number, and if I say here is a number plus 1, and I want to then double it, that's not going to bring me new friends, isn't it? Because that's kind of boring. I'm duplicating the code. I'm not making use of what I already created. So that's not going to really be a winner. So what do we want to do in this particular case? So here is an idea. We can take this particular function, which is incremented, and we are passing the data to the inc function, and we're taking the output of that. Similarly, we have a function called doublet in this particular case, which is going to return the double of the value. But what if we can take another function, and this function is going to take an input, but that's going to pass the input to the increment function, take the output of the increment and deliver it to the doublet, and take the output of doublet and then return it back as an output from there. So in other words, what we can do is we can compose a bigger function using these smaller functions by way of asking this to take the output of one function and pass it as an input of another function. And that function basically is the and then function that can be used to build that kind of a functional composition in the case of Java. So what you can do here is you can say, we'll call this as inc and, let's say, then is equal to inc and doublet. We'll call it as increment and doublet. And this is going to be inc dot and then. And we can simply call the doublet as a function right there, and we can create that bigger function, which we can pass as an argument to this inner function. So essentially, this becomes a function composition where we can thread together, so to say, the output of one function as an input of another function. We can start creating this functional hierarchy really nicely. So this to you becomes like a box where you don't care about the internals of the box. That becomes your function that you're going to work with. And if you really look at the print function at the very top right now, the print function doesn't know this, doesn't care about it. All that the print function says is, give me one function I can use, and I'm going to call that function, apply that function. But as it turns out, that function is a composite where we actually composed it as an increment and then taking the output and passing out to the doublet. So this idea can be used very effectively to build on to things that are much more interesting. But before we do, remember the good old decorator pattern. Do you remember the infamous example of the decorator pattern? The new buffered input stream, parenthesis new, data input stream, parenthesis new, file input stream, parenthesis, and you look at this and you say, my dear God, why did any human do this? And you then kind of have a doubt and you look up the dictionary. Maybe the word decorator means to take something nice and make it ugly, right? And so we lose faith in the word decorator. We don't use it. And that's a scary pattern. It's a beautiful pattern in concept, but we don't usually use it because we haven't really found a nice, pleasant way to use a decorator pattern. But what if a decorator can bring back the true meaning of decoration and look beautiful and elegant and easy to work with it as well? So to understand this, let's take an example of a class called camera. And my mind is corrupted. Anywhere I am, anything I do, there's a thread in the background that keeps thinking about programming for me. And I'm a big fan of the outdoors. I go hiking. But anytime I see somebody with a very fancy camera, and you've seen people like that, right? They have this beautiful camera with a lot of attachments, and they have these little lenses and bigger lenses, and they can take a bunch of lenses out, they can put other lenses, and they can focus. And every time they're enjoying the mountain, all I can think of is the decorator patterns, poor me. Because when you look at it, it's the same base camera that you're using, but you can replace the lenses to anything you want to. That's a classic example of the decorator pattern. I don't try to usually talk to these people, they didn't run away from me, but usually I kind of admire the camera and the decorator pattern in it. So the next time you see somebody with a camera, now you know what to think about. So the decorator pattern can be really, for example, let's say we have a color and I'm going to call it as a snap right there, which takes a color as an input. And all I'm going to do right now is simply return that input back to the caller. Just start with a little baby step right now. Let's say we'll start with that. So I know this is a bit scary, but we'll just use the color right now for now. So that's my little snap function I want to start with right there. So then I'm going to create a print function again in this case, where we'll say a print is going to take a camera as an argument right there, and all I'm going to do is to simply say, return, let's say, output, and we'll say camera, and we'll call a snap function, and let's go ahead and send a color. So new color, let's say 125, 125 and 125 as an example. So then, of course, I'm going to simply call the print function new camera and simply call that as a very first step. So we're going to call this particular function and have that really process that and return the result back to the caller at this particular time. So given this particular code, what we want to really do here is to start with something really simple, right? We have a camera object. Let's see what it's complaining about. It wants a semicolon or an expected. So this is going to be, let's look at line number 12. Okay, so there is one more of those that's missing. So that's basically a little 125, no big deal. However, let's take this a little further in here, if you will. So I can say private a function which takes a color and returns a color, and we'll call it a filter. Now, I want to emphasize here, this filter is not the filter as in the functional programming filter map reduce. There's a filter in the world where they use filters on the cameras, right? So you got a nice filter to filter out certain colors. That's a filter you want to create right here. But what I want to do here is I say filter, but I want to create a camera right there, and I'm going to say this is going to take a function, and this particular function takes a color and returns a color, but I'll call this as filters, if you will, as a var arg in this particular case. So now that I'm taking a var arg, we don't have to pass any arguments to the var arg, so that works really nicely. So in this case, I'm going to simply say a filter is equal to, given an input, I want to return that as an output. Let's start with a little baby step right there. And then I can say a var. In this case, we'll say a filter. And the filter is coming from the filters, if you will. Then we can simply say the filter is equal to filter and then, and I can simply say a filter, and I can provide that combination. And so we are really combining that using the and then function we saw a few minutes ago to build this collection of these filters. Then we can come back here, and that functional composition we created, we can simply say filter.apply and pass the input to it like so in this particular case. So in here, what we are doing is we have a function we created. So I'm going to bring in the function like so, and we can then simply say, here's a color. But where does this take us really? The beauty of this particular code really is that you can now go back to this and you can actually pass a filter to this particular function. You can say here is input coming in, and I want to take the input and make it brighter, or as you know, you can simply take that out and simply say color brighter, and you can pass nicely a method reference. And as you can see, the 125 became 178. Similarly, you can take that one, you can make it darker as well. And as you can see, the value is smaller than 125. But you know where I'm going with this? You could also start combining things like so. So you can say brighter, comma, I'm not sure why I would do this, but a darker as well. And you can see that it goes through the combination of those filters. So now you can start thinking about how you can combine these filters together. These could be policies in your application. These could be different processing of the data you perform. Maybe you want to cleanse the data. You want to mask some data. You want to transform some data. Whatever the operations you want to perform, each of those you can start combining them as a composite into your decorator, and you can build this decorator pretty easily. Now, obviously, in this particular case, you can put as many different combinations as you want to. No more of that scary new, and creating objects. You're basically using these functions as decorators, and you can compose these functions, and you can apply them in your code to the extent you want to. Now, we could stop at this point with this decorator, because it's from the user's point of view, you are able to pass no criteria or a bunch of them or any combination of them, so you can start putting together really nicely. However, if you really wanted to refactor this a little bit further to have some fun with this, you can do a little bit more on this as well. So in this case, you're taking an input and you're returning an input. Anyone remembers from math school a function that takes an input and returns the same thing, like a multiplication on a 1 or a addition on a 0? Anyone remembers what that function is called? There you go. You went to better school than I did. It's an identity function. That's correct. You remember that. So you can change this to a function.identity as a function you want to use. So that becomes an identity function. So it just simply takes the input and returns the output. Now, in this particular case, you have a collection of filters, which you are combining them into one filter. Any thought on what functional programming API function would do that for us? Any clue? That's right. I heard that from here. Reduce function. You nailed it. So what you can do is you can get rid of all of that, and you can say filter is equal to, and you can simply go back here and bring in a stream, if you will, and you can say here a stream of, and you can bring the filters in here, dot reduce, and the first one is your function dot identity, and the second one is your function and then, and of course this can combine the functions together to perform the job here as well very nicely, as you can see. So that becomes a functional equivalent of that function that we wrote a few minutes ago. So you're basically taking these functions and putting them together as a decorator. So you're saying, give me a collection of these functions, and I want to reduce them to one function, which is a composite of all those functions, and that becomes my decorator. And then, of course, once you receive it and store it as a filter, you just have one object on your hand, but that object is a composite of those functions, and you can just call functions on it. So that becomes a very interesting way to apply the decorator pattern. So once again, we can use lambdas and the functional programming and streams API to really build a decorator pattern, as you can see in this particular example as well. So that takes us to one other very interesting use of lambdas again, before I wrap this up with a little example of using sealed as a final example in here. So let's take an example of something that exists in Java, but it's been evolving over time. But I want to talk about where certain ideas appear really good at surface, but may not really go all the way through. So let's say we have a class called a resource, and the class resource, let's say, has a constructor, and where we can simply output, let's say, creating an external, let's say, resource. So this could be a file that you open, a database connection you open, a socket connection, something external to your application. And you know this, that automatic garbage collection is not instantaneous. So it may happen just about any time it wants to happen. And automatic garbage collection doesn't clear up external resources for us. So in this case, let's say we have a function called op1, which is going to simply output, let's say, op1, and we say return the current object like so. And then, of course, let's also say we have yet another function. Let's call this op2. And op2 is going to simply print op2 and return the object as well. But then we have a void finalize function, and the finalize function simply says output. Let's say in this case, we will simply say, what are we going to output just to symbolize this? We'll say cleaning up an external resource, let's say. So in this particular example, when I run the code, what is this going to really do is the question. So in this particular function, we have the op1 and op2 and the finalize function. Let's say we are going to create a function called a call, and the call function, let's go ahead and say in this case, is going to simply say create an object of resource. So we'll say resource is equal to, let's say in this case, a new resource. We'll call the resource dot op1, and let's also call resource dot op2 as well in this particular call. So let's fix the error on line number 5 right there. Public, this is going to be resource, and that's going to be the op1 function we're going to return. It would help to close this one. Let's go ahead and try that again. So, but notice it did not call the finalize method. What is the reason it did not call the finalize method? Well, the reason is if there is a lot of memory, the garbage collector says, I don't need to really collect garbage right now. So the garbage collector in Java is kind of like the garbage collector in my neighborhood. Just because I put the trash out doesn't mean they come and take it, right? So it says, the old man Venkat wants to put some trash, but I have better things to do. I'm not going to collect that garbage right now. So the garbage collector never really executed right there. Automatic, it's not instantaneous. Now, if they really wanted to name this function, they could have called it bad idea to begin with, right? Because the finalize really doesn't serve the purpose. In fact, it's so much so that in Java 9, they deprecated the finalize method. So if you have finalize in your code, and if you treat warnings as errors, you'll get an error in your compilation. They quietly removed the finalize method over the years. But this has been a contentious issue ever since. Because if you really think, if you think about it, the creators of this API really had a great sense of humor, in my opinion, because they didn't stop with this. They even created a function called system.gc. And this function, what does that do? Really nothing, as you can see. In this particular case, it called, but there's no guarantee it would ever call it. So they could have called it hope, if you will, because you can call it, and there's times when it's like, gosh, why is it not doing anything? It's very unpredictable. It may not really run it as well. So the question is, how do we deal with this? Well, it turns out that we want to be able to clean up these garbage at some point in time, but we want to be deterministic about it when we know we don't really need it. This actually happened on a project I was working on for a client on a consulting gig I had, and they really had a problem where the resources were not being cleaned up properly, and they didn't really know why it was until we started reviewing the code, and we found out that they were relying on finalize to clean up the resources. Unfortunately, that didn't go well. So then what did they do? In Java 7, a new feature was introduced called ARM, which stood for automatic resource management. So what does this automatic resource management really do? Well, you can go back to this and call this as a close method, but to do this, you implement, in this case, the auto-closable. And of course, by implementing auto-closable, you can come down to this code and you can say a try like so in here. And you can then say, I want to call these two methods, and I want this resource to be cleaned up, so to say, automatically, hence auto-closable, if you will. So in this case, it's saying incompatible type with auto. So let's make sure I call this properly, auto-closable. So let's try this again, closable. So auto-closable, with that, you can see that it's calling the cleanup at the very end. But when you look at this code, you had to use this object and within a try with resources, as we call it. And then you can call the method you are interested in calling, and at the end, of course, is going to release that particular object. So you may look at this and say, great idea, shouldn't we be happy with it? The problem with this approach is, what's going to happen if I don't use the try after all, and if I write the code like this? Let's think about it. Will it give you an error? Anybody thinks it's going to be an error? No, not really. Will it at least be a warning? No. So what is it going to do? Absolutely nothing. But deep down, you knew this already, right? Because you know not to ever trust a feature with the word management in its name. So that's not going to do anything for you, really. Well, the problem is, I want code to be deterministic. I want code to be intentional. And it's my problem as an author of a code if I want that garbage to be released at the proper time. So this is the reason why I would recommend, let's fall back a little bit. And let's just remove that for a second, the auto-closable, if you will. So when you run the code, obviously the resource is not being released. So what are we going to do? I'm going to first of all make the close method a private method. Now, clearly you cannot call that method directly, so that's okay. But then what are we going to do? I'm going to make the constructor itself a private as well. Now, clearly, you cannot create an object directly if the constructor is marked private. So what are we going to do? I'm going to go back to this code and say resource.use. And this is where this beautiful pattern called the execute around method pattern really comes in. And you can then say, here is a resource I'm going to receive. And I'm going to call, in this case, the resource.op1. And I'm going to then call the resource.op2. And then in the end, I'm going to close that particular function call. So essentially, you call a use method, and there's no way to create this object directly anymore. And so you can use this to implement certain nice policies in your code. So I'm going to go back and bring in the function right now. And I'm going to say, in this case, a public, let's say, static void use. This is going to take a consumer, and the consumer is on resource, and we'll call it block. You can call it whatever that makes sense in your application. And then I'm going to simply say, here comes a resource I'm going to create as a resource equal to new resource. I wrap that into a try and finally block. And then within this, I'm going to say resource.close, which is a private method. And then within this, I'm going to yield to this and say accept and pass the resource reference over to that particular function. So when you look at the use method, the reason this is called an execute around method pattern is that you want to do some work, but around it, you want to do some pre-op like you see up here, and you want to do some post-op like you see down here as well. So around your logic, you can implement policies. You can do security checks. You can do transaction boundaries. You can take care of any other things you need to perform. So there is a padding around which you can say, here you go, I want to do some work, yield control to you, but when you come back, I'm going to finish up some operations on it. So as a result in this particular case, you can see the resource cleanup is happening in the end automatically. But the nice thing about this is you don't risk somebody creating your object and then losing control of the proper cleanup or any other logic you need to perform. In some languages like Scala, they call it as a loan pattern. It's as if you get a car on loan, and before they rent the car to you, hopefully they clean it up really well. And then when you return it, they check for damages, more so in my case generally. But the point is, there's a pre-op and a post-op that happens, but I hope they don't care where you drive around. That's your job to take the car around, but there's a pre-op and a post-op, so there's an execute around method pattern. There's a very, very powerful pattern here, as you can see in this particular case. So to wrap this up, I want to talk about one other pattern which is really powerful. And this gives an opportunity for us to create a hierarchy which is really closed. For example, if you are developing, let's say, an application with plugins, and you want your users of your code who are providing the plugins to implement some interfaces, but maybe there are interfaces you don't want them to implement, you want them to only use those interfaces. So how do you really create a bunch of interfaces whose classes implementers are controlled by you and not by others? There are really crude approaches I've seen people take. You can do runtime checks and blow up. You can write your own annotation processor and spend the time maintaining it, and it becomes very expensive over time. But here's a nice way in Java to implement this idea using what are called sealed classes. So to understand this, and they call it sealed classes, but it could be sealed classes, could be sealed interfaces as well. So I create a traffic light, for example, and in this case, I say a traffic, let's say call this as traffic light is equal to new, let's say red light. So I create a traffic light. I'm going to simply output the traffic light like so. But I want to really see where this traffic light is. So let's go ahead and create an object of this, or the class for traffic light. So in this case, I'm going to say a traffic light.java. And here I'm going to say public. Let's say in this case, we want to create a public, we'll call this as interface. We'll call it a traffic light, if you will. And then I'm going to say, mark this as a public, let's say sealed, like so. Then I create a final class called red light, and which implements, in this case, the traffic light, like so. But I'm also going to create, let's say, a green light and maybe one more a yellow light as well. But I created these as sealed interface with these classes like so. There are a few other variations that we won't go into right now, but this is a good start for our purpose. So as you can see, I was able to do it. But if I were to go ahead and create my own final class here, and let's call it as a broken light that I want to create to implement, in this case, the traffic light, you will notice that I don't have permission to create it. So what's the problem in this particular case? If I were to create implements, of course, implements the traffic light, notice the error. It says class is not allowed to extend sealed class traffic light. Well, that's because in the definition of the traffic light, we said sealed, and its members are restricted to the numbers that we permit. So this gives a nice idea, a nice way for us to implement a closed hierarchy of classes without having to devise methods on our own with a lot of expense and trouble and error-prone approaches. This becomes a nice way to control the hierarchy. Not only do we benefit from the controlled hierarchy, this also nicely works with pattern matching syntax, where we can have completeness in terms of all the different variations being checked in as well. And I think this is going to be really a beautiful approach. We had a similar thing available in terms of enums in the past, but this really takes that idea and brings it to general purpose programming, and we can benefit from the sealed classes. And if you really wanted to, you can also create the sealed classes by using a permits class right here, and they can be in other files within the same package or within the module as well. So that gives you the power. So that brings us to the end of this session. We talked about different patterns. We talked about how we can benefit from them using some of the features and how the language has evolved. It's a great journey, and I think we're also going to see more of these patterns just go into the language as features as time goes on. I hope this was useful. Thank you for joining.